In this video, we're going to take a look at projectile motion for the problem that I've drawn a picture for here. So we have a cliff. I forgot to give the height of the cliff. Let's see, let's make that's 40 feet. Okay, and from the edge of the cliff, we're going to fire a projectile at an angle of 35 degrees above horizontal. And we'll have a number of questions we'll ask about that, about the flight of the projectile. We'll be interested in things like what's the horizontal distance that it travels before it hits the ground? What's its maximum height? How fast is it going when it hits the ground? What angle does it hit the ground at? And we'll calculate the actual distance traveled through the air. So let's go ahead and get started on this. The way we need to begin is we need to figure out our position vector for the projectile. Okay, so to do that, what we're going to have to do is take what we know about its initial speed. So the v sub 0 that I've shown, the 92 feet per second, is the magnitude of its velocity vector at time 0. And that vector forms an angle of 35 degrees from horizontal. So I'm going to draw a picture over here to the right that we'll use to figure out some things. So let's just put our vector in here. And so this has got length 92. And there's an angle here of 35 degrees. And so what we want to do is form a right triangle here, like this. And what we need to do is figure out the horizontal and vertical components of the velocity at time 0. So we're going to call this here, this is v0x. Let's call this v0y. Okay, so those would be the horizontal and vertical components of the velocity at time 0. And what we can see is that the v0x is on the adjacent side of a triangle, and the 92 is the hypotenuse. So what we have is that the cosine of 35 degrees equals v0x over 92. If we multiply both sides by 92, we get v0x equals 92 times the cosine of 35 degrees. And to the nearest foot, that comes out to be 75. Actually, it's not feet, it's feet per second, the same units as the 92. By the same sort of reasoning, the v0y is 92 times the sine of 35 degrees, and that comes out to the nearest foot to be 53 feet per second. So combining these two, what we get is that the velocity at time 0, and that's the velocity vector at time 0, is equal to 75 and 53. Those are its components. Okay, so let me fix that little vector arrow. It didn't look very nice. Okay, so there we go. So now we're ready to figure out what our R of t equation looks like. Before we do it, though, what we need to do is put in a coordinate system, and we'll put in the coordinate system in sort of a standard way we'll always use. We'll put the y-axis vertically through the point where the projectile is launched. So there's our y-axis. And we'll put the x-axis at ground level. So there's the x. So what happens is our projectile, what v sub 0 is showing us is that the projectile's moving horizontally at a rate of 75 feet per second, and we're going to ignore air resistance. So what happens is every second this thing's going to go 75 feet. It starts at 0 feet, so the horizontal position at any time is simply 75 t. Now, the vertical position is going to have a factor of, or a component that's 53t. That would give us the height at any time if it was launched vertically at 53 feet per second, but that would only be if it started at the ground and there was no gravity. So the fact that it starts at a height of 40 feet means that we really need to add on 40 feet so that when we put in 0 for t, we'll get a height of 40. And then, of course, there's a negative effect due to the gravity. And when we're working in feet and seconds, that's always going to be a negative 16t squared. So this is what our position vector looks like at any time. It's likely that along the way when we're trying to do things that we'll need the velocity vector. So let's go ahead and just find it right now by taking the derivative. And that's 75 and then negative 32t plus 53. And you can see that if we put in 0 for t, we in fact get our initial velocity vector, 75, 53. So let me take those and let's go on to, well, let's keep using this page for a little bit, and then we'll go with a new page in a bit. So let's ask our first question. The first question we'll ask is, how far does the projectile go horizontally? I'm going to abbreviate projectile as PROJ. How far does the projectile go horizontally before it hits the ground? So in other words, what we're asking for is this distance right here. Okay, so that's a question. When we see the how far, that's a position question. Okay, and that question is about horizontal position. So it's going to come from the horizontal component of position, the 75t. That's where we're going to get our answer. And the only question is, what do we put in for the time? Okay, so what we need to do is figure out what is the time when it hits the ground. So in other words, let's go over here. I'm looking at where it hits the ground, and the question is, what is the time then? So we need to know something to help us find the time. And what we know is that when it hits the ground, that its vertical height is equal to 0. So that's this part here gives us the vertical position, and this equals 0 at this time. Okay, again, the height will be 0 when it hits the ground, and so if we set that equal to 0, we can figure out what time it hits the ground. So we've got the equation, negative 16t squared plus 53t plus 40 equals 0. So we have to solve that for t, and that's going to be a bunch of quadratic formula stuff, blah, blah. And when we apply the quadratic formula to that, what we're going to find is that t equals negative 0.63 seconds and 3.95 seconds. Now, the negative time is obviously before this thing's even launched, so that's not useful to us. And so it's the 3.95 seconds that we're interested in. So this is the time when it hits the ground. All right, so let's see. What was the question we were trying to answer? The question was, how far does the projectile go horizontally? We recognize that that's a question about horizontal position, which is 75t. So we needed a time to put in there to multiply by 75. And so the distance, the horizontal distance, is equal to 75 times the time we just got, which is 3.95. Okay, we multiply those together. I'm going to round all the distances to the nearest whole foot. So what we get is 296 feet. So that's the distance that the projectile travels before it hits the ground, 296 feet. So let me put that, the picture's pretty crowded. I'm not going to bother putting that on the picture. So let's go ahead and move on to a new page and answer a few more questions. So the next question I have is, what is the maximum height? Let me put back in the R of t and V of t vectors. So again, R of t was 75t and negative 16t squared plus 53t plus 40. And the V of t, again, was 75 and negative 32t plus 53. So the next question we'll ask is, what is the maximum height reached? Okay, so again, when we see the maximum height, this is a question about position, but this is about vertical position. And vertical position is here. It's negative 16t squared plus 53t plus 40. So that's where we're going to get our answer. The only question is, what do we put in for time? And the key is this. Okay, so let me draw a little picture here, a little movie of our projectile. So the projectile, as time goes on, is going like this. Now, if we were to look from above and look at the projectile, this is what we would see. We would simply see something traveling along at a constant speed. If we looked straight on vertically at the projectile coming at us, we would see something like this. The projectile would go up, and then it would go back down. So let me draw that again. Up and down. And notice right there at the maximum height, the vertical velocity is 0. On the way up, the vertical velocity is positive. On the way down, it's negative. And in between, right when it reaches maximum height, the vertical velocity is 0. Well, the vertical velocity is right here. It's the negative 32t plus 53. So let's set that equal to 0. And solve. So we've got 53 equals 32t. And t, it turns out, comes out to be 1.66 seconds. So that's the time. And again, though, remember our question is, what's the maximum height, which comes from the vertical position. So what we need to do is take that 1.66 and put it into the vertical part of the position vector, the negative 16t squared plus 53t plus 40. So let's go ahead and do that, and that'll give us our maximum height. So the max height is equal to, so we have negative 16 times 1.66 squared plus 53 times 1.66 plus 40. All right, so we make that calculation, and it turns out that what we get is 84 feet. Okay, so I'm going to stop this video here, and we'll take this same problem up on another video, and we'll do a few more things there.